The Octonians. What happens when we come to the end of the line of the division algebras as we know it? Well, apparently, it's been brought to us by Graves. Yes, yes, yes. Happy Halloween, puns intended. You all know what that means. We conjecture
Although
ahead.
this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might
Yeah,
be just hyper Rulial Turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So, yes, yes. What the heck am I trying to do? What type of terrible joke am I making? Well, it's this type of terrible joke that I'm making right here. Okay, well, that's the exact same image because I was showing that particular tab and not the window because I'm a total noob at this live internet. Yes, the Octonians were brought to us by John T. Graves. As we can see here, he was a gentleman from the 1800s here, and here we go. The whole moral of the story. Oh my god, I can resize. There we go. That's a little better. All right. Enhance. All right. For many years, yes, I'm skipping over the gentleman's whole life because I'm that type of person. I am a masshole born and raised, of course. For brevity's sake, for many years, Graves and Hamilton maintained a correspondence on the interpretation of imaginaries. I should probably tell what we're talking about. The Octonians, that's this thingy here. I'll show them a little logic graph of it. In mathematics, the Octonians are a norm division algebra over the real numbers. A kind of hyper-complex number system. Don't worry, we're not going to get super complex here. But the Octonians are usually represented by the capital letter O, or those bold-faced theirs. What are they? They have twice the number of dimensions of the Quaternions. What the heck's a Quaternion? Again, links to all the stuff that's in the doobly-doo below. Again, take Wikipedia for what it's worth. Not a bad starting position, especially when I see Team Wolfram going on it for a first level approximation for different, more uncontroversial things, at least for now. Uniquaternians, known as versors, provide a convenient mathematical notation for representing spatial orientations and rotations of elements in 3 dimensions. Basically, that whole, it's like, all right, we have the X, we have Y. What if we just had a number line? You went 1, 2, 3. What if it was to rotate around? That's where we usually use the imaginary number, I. Yes, it's the number I. It's the square root of -1. Why? You're not supposed to actually get answers for like you're not supposed to have something like that that's negative. So basically, it doesn't. Basically, 4i loops you around. It's basically a circle. It's also part of the HF8 minimal arena construction. Uh, this is just for my own sake and for anybody that might be a wee bit interested in this stuff. But Fractal Rick, what's going on, my friends? Thank you for joining. Happy Halloween to you all. But okay, so basically, imagine like taking a sphere, and then basically you're going to plot your points, yada yada. All right, the Octonians are double of that. What does that mean? I don't really know. But back to our friend, Mr. Graves. So Hamilton discovered the Quaternions, and it was to Graves that he made on October 17th. Oh, not that long ago, except a few hundred years. His first written communication of discovery, in a preface to the lectures on Quaternions, and in a prefatory letter to a communication to the Philosophical magazine in December 1844. Are acknowledgments of his indebtedness to Graves for stimulus and suggestion. Oh, sounds like they got along. They were able to get the old noggins jogging of each other. I also enjoy when that happens. Immediately after the discovery of Quaternions, and before the end of 1843, Gray successfully extended to 8 squares, Euler's 4-square identity, and went on to conceive a theory of octaves, now Octonians, analogous to Hamilton's theory of Quaternions, introducing 4 imaginaries additional to Hamilton's I, J, and K, and conforming to the law of the modulus. Octonians are contemporary, if abstruse area of contemporary research of the standard model of particle physics. Hey, colleague. Oh, yes, yeah. Oh, there's very interesting things going on here. All right, so let's take a step back. Let's go to our friend Wolfram Alpha real quick. Just type in Quaternion. I tried doing the generic logic thing. It didn't immediately come up. I haven't figured it all out. I didn't want to use a notebook, but Quaternion group. All right. So what are the main things here? Basically, the whole. Actually, no, they end up saying it on. Hold on. We'll go to Math World. All right. Quaternions are members of a non-commutative division algebra. So basically, a lot of times for like maths and stuff, like if you multiply, it doesn't really matter the order in which you multiply things. It matters here. So, all right. So the Quaternion was first invented by William Rowan Hamilton, who we just touched upon right there. The idea of quaternions occurred to him while he was walking along the Royal Canal on his way to a meeting of the Irish Academy. And Hamilton was so pleased with the discovery that he scratched the fundamental formula of quaternion algebra. I squared equals j squared equals k squared equals ijk equals -1. See, I feel like that's something. If I realize something like IJK, oh, JK there, I don't really think that was a thing in that parlance at the time. It makes me tee-hee. Into the stone of Burham Bridge. Yeah, basically, apparently he wrote down into a journal, according to Professor Wildberger, and then he also etched it with his pocket knife into the bridge. But, okay. So basically, you got those things there. Okay. So according to Wolfram Alpha, of order 8, notation Q8, it's the fifth finite group of order 8. It's a dicyclic group of order 8. Oh, excuse me, those are the isomorphic groups. Okay. I didn't dive that deep into them right now. I just know there's a lot of pretty things going on there. We got our 1, our -1. We've got our i's. We've got our j's. We go down to, oh, look, -k. Oh, I see what they're doing there. Cool. All right, so what the heck's an Octonian? Let's go to Wolfram Alpha. Okay, following the same thingamabobber, the set of Octonians, also sometimes called Cayley numbers, and denoted O, consists of the elements in a Cayley algebra. Typical Octonians of the form A plus B I 0 or plus C I. Basically, you go through all those permutations. All right, where each of the triples, groups of 3 over there, behaves like the Quaternions. Octonians are not associative. They have been used in the study of 8-dimensional space, which in the general rotation is that crazy thing right there that didn't immediately work in Wolfram Alpha. According to our friends at Wikipedia. In mathematics, the Octonians are a norm division algebra over the real numbers. It's kind of hypercomplex number system. Okay, yeah. We already went over that. They're not known as well as the Quaternions in complex numbers. Yeah, okay. Transformations. Yada. Okay. Decompose this into different matrices. So what's the whole logic? You're able to go all over. This one, there actually might be a misprint. That's why I used this guy over here. Okay. So what is this? The idea is you're able to continue to go around this triangular-like thing. It also has a circle in the middle, so it's able to go through some rotation. No, it goes this way in the reference frame. Okay. So what do we have here? All right. We got 1. We go to 2. We go to 3. We go to 4. We go to 5. Oh, we go to 6. Oh, we go to 7. And then I think we loop all the way back around there. Again, I'm not a professional mathematician. I just know it's a really pretty thing that I've seen in other contexts before that seems to be pretty interesting over there. What were some other interesting things about it? What do we want to get to? Of tuples, which are the combinations of real numbers. Okay, every Octonian has a real linear combination. Where was it? Okay. So what's also, the Kronecker delta. I've seen that friend before. Okay. So most off-diagonal elements of the table are antisymmetric. making it almost a skew symmetric. So skew symmetric matrix is a square matrix whose transpose equals its negative. Oh, is that why it goes like quaternions were like 1 and -1? It's sitting in a range there. It's almost like maybe you can make some form of a spherical-like object, perhaps a hypersphere, so to speak. And you could use that as perhaps a coordinate system, perhaps a transform system. Again, I don't know this. I'm just a dude on the internet. Hey, upcycle. Yes, yes. I also kind of think that too because I remember when Dr. Weinstein had his arch nemesis or something with Garrett Lisi, who has the Pacific Science Institute out there in Hawaii. Voss has a lot of cool pictures on Instagram and stuff, but no, that was his big thing, and I know he's done a bunch of work on it, and it apparently seems to line up for about was it like 240 or so of the different parameters that might be in the standard model. It seems to line up extraordinarily well. Doesn't quite make it. At least I haven't seen it yet or heard anyone say that. Oh, the other interesting thing. All right. Each of these 480, so I assume those are going to be reflections of each other. So probably particle, antiparticle. Again, I'm not an E8 professional at all. I'm just following just the logic that pops into my head. Merry Halloween! Yes, Bone. Yes. Oh, well, it seems like Rick's saying that Cold Fury in 2017 tied all particles in the standard model to physics to the Octonians. Huh. That's really neat. I'm going to have to check up on that. Now, wait, was it specifically within E8? Actually, no. I think aren't the Octonians? I think we're going to get to that. I believe they're. I think they literally said like a perfect double cover of E8, which that agrees with me. I'm all right with that. But each of the 408 definitions is a variant of the signs under some 7 cycle of points, 1 through 7. And for each of the 7 cycles, there are 4 definitions, differing by signs and reversal of order. Okay, so you're able to set up looks like your logic tables in different ways. Okay. And again, this is all on Wikipedia. There's plenty of stuff out there. All right, cool. All right, Quaternions, jump, up. All right. So, so is there something past the Octonians? Of course, you can basically keep using the same, I believe, the Cayley-Dixon method there to get the Sidonians. That would be a 16-dimensional thing. So, in abstract algebra, the Sidonians form a 16-dimensional, non-commutative, non-associated algebra. So the whole non-commutative, they got this cool little thing. So basically, if depending on the order you put it is, if it's commutative, it doesn't matter. Kind of like we were saying before. With the Octonians, it does matter the order because the logic can go in the different ways there. Now, however, the Octonians are the last of the division algebras, so I believe the associative, they still have this, do they? Yeah, I always get them confused. Where are we? Non-commutative and non-associative. Okay. So basically they have an alternative. So basically it ends up doing this thing here. So if you multiply x by xy rather than doing your standard, all right, x squared and then that, and then y, x times y goes just xxy. It does this little thing down here. So, and again, I'm not a math professor or anything. Don't use this to study for any exam. I'm rapidly conjecturing here. But, oh, I'm gonna have to check that out. That's thank you, Rick. That's that's very relevant. Thank you, sir. Ah, see, this is why I like talking to people. And you do this, and you never. Hey, the internet, for better or worse, you never know who's watching. Sometimes you do, but you meet a lot of really interesting people that have a lot of really cool ideas, and there are just crazy people like me too. But all right, non-associated alternative power. Associativity, that was the, okay, weak form associativity. Uh, yeah, basically you lose your division algebra properties there. To at least, as far as I know, yeah. Okay. So, I believe the Cayley-Dixon thing is you could continue to power associate zero divisors. Yeah. And it starts to, okay, the real numbers, all these things, complex numbers, not ordered. Quaternions, you lose commutativity, you lose associativity. Ah, okay. After the Octonians, things seem to get a little boring, if you would. Is it boring? I don't know. I'm totally biased because we kind of live in, at least we have the whole 3+1 thing. So it kind of sounds like 4. Is it exactly that? Not for the speculation at this time. But we'll go back real quick because I believe there was one more thing before I get completely off topic like I already was there. But actually, I'm not even going to go into. Okay, that was actually the G2 group. Professor Penrose was talking about that before. So, but basically, you can also run these things called the Mofang loop. The mathematics of Mofang loop is a special kind of algebraic structure. It's similar to the group in many ways, but need not be associative. Mofang loops were introduced by Ruth Mofang. Smooth Mofang loops have an associated algebra, the Mikhailov algebra, similar to, in some ways, to how a Lie group has an associated Lie algebra. Oh. So I get all these things, and I can totally biased the subset of the unit norm Octonians forming a 7-sphere in the Octonian logic. It's closed under multiplication and therefore forms a Mofang. Oh, okay. Okay, subset of the unit norm under 240, like they were saying before. Okay, so it seems to be a logical ordered process there. See? I'm learning more than just what I had skimmed earlier. I did do some reading for some other things, but oh, there's so much to explore. So much. Oh my God. The left and rights reminding me of Conway's games and stuff. Okay, we don't need to. It's Halloween. Going on for almost 20 minutes about stuff that I know very little about. But at least from doing this live stream right here, I at least know places to go that I can learn a lot more interesting things. So, thank you, Rick. Thank you, Callie. Thank you, Bone, Upcycle, Fractal, and everyone that's joining now and temporally in the future. So, yes, all bad puns aside, take care of yourselves. It's a wacky and wild world out there. I'm not a dietitian, but I do like candy. So, peace out, everybody.